All right, Kim, this is Miss Boston. We're going to go on to naming compounds. This is your naming flowchart. I will post it in the assignment for you. And we're going to learn how to use this naming flowchart so we can start to learn how to name compounds. So hopefully you got a little bit better at the charges, and that's going to help you naming compounds. So let's deal with the top of the flowchart first. First box that you're going to start in says, does the compound start with H+, not including H2O or H2O2? H2O is water, H2O2 is hydrogen peroxide. So that's not considered to be starting with H+. We'll deal with what that means to start with H+ later. So let's just start with the simple one that we already know. So starting with H+ would mean in this very first position here, that would be a hydrogen. That is not a hydrogen. If it's anything but hydrogen, you're going to say no, and you're going to follow this particular arrow. Then it says, is the compound binary? Just as you'd expect, the word binary means two. There is sodium and there is chlorine, so the answer is yes, that is 2. And then it says, name ends in IDE. All binary compounds end in IDE. And then it says in the next box, is it ionic or covalent? Ionic has a metal first. So you go to the periodic table of the elements and you say, is sodium a metal or a non-metal? And believe it or not, sodium is a metal. So it says, does this metal have a variable charge? So remember we went over our variable charge metals. We know that sodium's an alkali metal, which is a fixed charge of +1, so it's not that. But the variable charge metals you could make note of are our 3 musketeers, our lowest L, and then tin and lead. So if it's not one of these, you're going to say no. But alkali metals are always fixed charges. So we're going to go down the no route. It says name the cation. And then the anion stem plus IDE. So we're going to take chlorine, knock off the ending INE, and change it to IDE. So it's sodium chloride. Let's do a couple more just like that. Ki doesn't start with H+, it starts with K. It's binary because it's got potassium and iodine. It is ionic because potassium is a metal. The metal does not have a variable charge because it's not one of our 8 that we need to look out for. And potassium is a fixed charge metal. So then it says name the cation, potassium. And then we take iodine and change the ending to IDE for potassium iodide. Let's do a couple more. Doesn't start with H+, it starts with calcium. It is binary because it's got calcium and fluorine. It is ionic because calcium is a metal. Calcium does not have a variable charge. It's not one of our 8, and it is an alkali earth metal. Those are these fixed charges. So we're going to name the cation calcium. And then change the ending of fluorine to fluoride, like such. Remember, it's fluoride, F-L-U-O-R-I-D-E, not flouride. That is every chemist's pet peeve. So let's do a couple more. How about, doesn't start with H+, it's binary. It is ionic. Lithium does not have a variable charge, so it is lithium sulfide. Does this compound start with H+? No, it starts with aluminum. Is it binary? Yes, it has aluminum and oxygen. Is it ionic? Yes, aluminum is a metal. Does this metal have a variable charge? No, it's not one of these 8 right here. Aluminum is a fixed charge, always has a charge of +3. So this is aluminum oxide. And this is how we name fixed charge metals in binary ionic compounds. Now let's learn how to name compounds that do have a variable charge metal in them. So we'll start again up at the top here. Let me pick a compound. How about FeCl2? So we'll start at the top and it says, does this compound start with H+? Well, iron's in the first position. Hydrogen would have to be in the first position for you to say yes. So we're going to go down the no route. Does not start with H+. Is this compound binary? Yes. Iron and chlorine are the two components of this compound. Is it ionic or covalent? Well, iron, if you look on the periodic table of the elements, is a metal. So we're going to go down the metal route. This is an ionic compound. Does the metal have a variable charge? Well, let's look. Yes, it does. So it says find the charge, name the variable metal with a Roman numeral or the traditional, then anion stem plus IDE. That sounds like a lot, but let's pick through this. It says first find the charge. Well, remember, we can do the algebra if you like. Your variable charge metal is always the X, because we don't know what iron, it's one of our 3 musketeers. It's either +2 or +3 for us. We don't know which one it is right now. We do know that it's attached to 2 chlorides that have a charge of -1. And it is a compound, so it adds up to 0. So X is +2. That means the charge on iron in this compound is +2. Or you could simply recognize, you do not have to do all the algebra every single time. You can recognize that there's 2 -1s in back, so there has to be 2 pluses in front. So this is iron 2 chloride. Let's try another one. Let's do Cu2O. So again, we're going to start at the top. Doesn't start with H+. It is binary. It is ionic. In this case, the metal does have a variable charge. So we're going to find the charge on the ion. So we can do the algebra and say, this is a tricky one. This one trips people up all the time. You can say that there's 2 coppers that I don't know the charge of, but there's 1 oxygen that I do know the charge of, and it's a compound, so it's going to add up to 0. So the charge on copper in this compound is +1. So this is copper 1 oxide. Okay, another one. Doesn't start with H+, it's binary. I'm going to go through this quickly now because we know that looking at this an ionic compound that cobalt is in the beginning of. Cobalt's a variable charge, so I got to figure out what the variable charge is. I can do the algebra because there's 2 cobalts I don't know the charge of. There's 3 sulfurs that are -2, and they are compounds, so they add up to 0. So 2x minus 6 equals 0. So x in this case is +3. So this is cobalt (3) sulfide. We'll do a couple more. We know tin's a metal, so this is a ionic compound that is binary. This is a variable charge binary compound, and the variable metal involved is tin. So I got to figure out what the charge on tin is in this compound. There's 1 tin that I don't know the charge of. There's 2 oxygens that are -2, and it adds up to 0. So x minus 4 equals 0. This is another one that if you decide you want to skip steps, you got to be careful because there's 2 -2s in the back. So this is tin 4 oxide. I'm going to do one more. I know that lead is a metal, so this is a binary ionic compound with a variable charge metal on it, which is lead. Now let's look at what I'm talking about here. Iodine's always a -1, but there's 4 of them back there. So lead's got to be a +4. So you can do that where you say, I know I have 4 minuses in back, I have to have 4 pluses in front. Or you can do the algebra every time. You just have to be careful of the points that trip people up. So this is lead 4 iodide. And that's how we name binary ionic compounds with variable charge metals.